Hello and welcome to today's lesson on formalizing pressure. In this lesson, we'll begin by building on our intuitive understanding of pressure. Next, we'll introduce the equation for pressure and outline how it aligns with our intuitions. We'll take time to familiarize ourselves with the units involved in this equation. Finally, we'll apply the equation to some problems to consolidate our knowledge. Let's get started. Let's begin by building on our intuitive grasp of pressure before we formalize it with an equation. From the particle models of matter unit, we've learned that pressure can be thought of as the force exerted by particles when they collide with the walls of their container. We also know that if you increase the force acting upon a surface, the pressure increases. For instance, when carrying a heavy backpack, the increased weight, force, exerts more pressure on the ground, causing deeper footprints. This is because the same force is distributed over a fixed area, leading to higher pressure. We also know that if you increase the force acting upon a surface, the pressure increases. For instance, when carrying a heavy backpack, the increased weight, force, exerts more pressure on the ground, causing deeper footprints. This is because the same force is distributed over a fixed area, leading to higher pressure. If you decrease the area over which this force is distributed, the pressure also increases. For example, if you stand on the sand with both feet, your weight is distributed over a larger area, resulting in broader and shallower footprints. If you lift one foot, the same weight is now concentrated over a smaller area, increasing the pressure on the sand and leaving deeper footprints. These ideas suggest that pressure is directly proportional to force and inversely proportional to area. Hence, the larger the force or the smaller the area, the greater the pressure. With that intuition in mind, we introduce the formula for pressure, which is pressure equals force divided by area. This aligns with what we expected, because as the force increases, pressure increases, and as the area increases, pressure decreases. To fully understand this equation, though, let's break down its variables. First, we have force. Force is defined as the magnitude of the force applied perpendicular to a surface. Force is measured in newtons. It's important to note that only the component of force that is perpendicular to the surface contributes to pressure. Then we have area. This is the surface area over which the force is distributed. Area is measured in square meters. A smaller area will result in a higher pressure if the force remains constant. Accordingly, pressure is the force exerted per unit area and is measured in pascals. 1 pascal is equal to 1 newton per square meter. This unit helps quantify pressure in a precise manner, which is particularly handy in various scientific and engineering contexts. Let's apply what we've learned to a few specific problems to consolidate our new knowledge. Imagine a car with a weight of 14,000 newtons resting on 4 tires. Each tire makes contact with the ground over an area of 0.05 meters squared. Calculate the pressure exerted by each tire on the ground. Firstly, identify the force and area. Since we have the total force exerted by all tires, we need to work out the force for a single tire, so we do 14,000 newtons divided by 4 to give us 3,500 newtons. We know the area of each tire in contact with the ground is 0.05 meters squared. We can then use the formula to calculate pressure, giving us 3,500 divided by 0.05, which equals 70,000 pascals. So the pressure exerted by each tire on the ground is 70,000 pascals. Question 2. A book has a weight of 10 newtons and it lies flat on a table. The area of the book cover in contact with the table is 0.2 meters squared. Calculate the pressure the book exerts on the table. First, identify the given values. We know the force is 10 newtons and the area is 0.2 meters squared. Then we can apply the pressure formula. Therefore, the pressure is equal to 10 divided by 0.2, which gives us 50. Thus, the book exerts a pressure of 50 pascals on the table. Finally, question 3. Consider a scenario where a chef applies a force of 100 newtons perpendicular to a knife blade that has an area of 0.001 meters squared. Determine the pressure exerted by the knife. First, determine the no values. We know the force is 100 newtons and the area is 0.001 meters squared. Then use the formula for pressure and plug in our known values. We can then work out the pressure, which is 100,000 pascals. Therefore, the pressure exerted by the knife blade is 100,000 pascals. By working through these examples, you can see how the equation allows you to calculate the pressure in various situations. This skill is essential in understanding and solving problems related to forces in fluids and other contexts. In today's lesson, we started by building an intuitive understanding of pressure, recognizing that increasing force and reducing area both lead to higher pressure. We then introduced the formula for calculating pressure, defining the key variables. We also discussed that pressure is measured in pascals, where 1 pascal equals 1 Newton-meter squared. This lesson provided a comprehensive understanding of how to calculate and interpret pressure in various scenarios, which is essential for analyzing forces in fluids and will be fundamental for more advanced physics topics. Watch the rest of the GCSE physics course at Sophos Education.